In this segment, we're going to look at isotropic, homogeneous, uniform, and the cosmological principle. Let's start with isotropic. In cosmology, isotropic is the characteristic of the universe by which, in its general properties, the universe looks the same in every direction. Let's first look at the word isotropic. So here you are, and in every direction you look, you see, let's say, the color blue. So therefore, it looks the same in every direction. You see a blue color. Let's say you look a little further out, and you see the green color. Everywhere you look, a little further out, you see green. Once again, you look a little bit further out, and everywhere you look, you see the color red. Each one of these is an example of isotropic. Notice the first ring, you see blue everywhere. The next ring out, you see green everywhere. And the next ring out, you see red everywhere. So isotropic means that everywhere you look, you see the same thing, but it doesn't have to be exactly the same along the same line. So as long as the rings are the same, as you look out, then you can say everything is isotropic. Of course, another example is that everywhere you look, you see the color yellow, and it doesn't matter how far out you look, you always see the color yellow. This also is an example of isotropic. Let's move on to homogeneous. Homogeneous in its broad term means the same in all locations. In cosmology, homogeneous describes a universe in which observers in any location of the universe would observe the same general properties on the large scale. So let's once again put you in the universe, and this time let's give some kind of coordinate system here. Let's give a north and a south and an east and a west based on the galactic plane and looking top down on the galactic plane. And you're in this universe, and you look off in the northwest direction and you see the color green. And then you look off in the northeast direction and you see the color red. And then you look off in the southeast direction and you see the color yellow. And then you look off in the southwest direction and you see the color blue. Now what homogeneous means is that if there was an alien in the universe, then it would observe the same general properties. So let's put an alien as the letter A, and we'll give it the same coordinate system, and it is going to see the same thing. So if it looked in the northwest direction, it would see green, and if it looked in the northeast direction, it would see red, and then if it looked in the southeast direction, it would see yellow, and if it looked in the southwest direction, it would see blue. So here I just said the general properties on the large scale, and I arbitrarily chose colors, but it could have been mass, or it could have been number, or some other property. So notice two big differences between isotropic and homogeneous. If we go back to isotropic, what you see is that along the radial path, so here's along this radial path, you see that the colors can change. But when we go to homogeneous, along the radial path, everywhere you would look would be the color red. So isotropic is not the same as homogeneous. Let's look at it another way. If you look at homogeneous, you see we went from green to blue to yellow to red in the counterclockwise direction. But if we go back to isotropic and we just picked one ring, let's say the red ring, we went red, 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 all the way around in the angle direction. So isotropic is not the same as homogeneous. Now let's look at uniform. So uniform in cosmology means is where the universe is both isotropic and homogeneous. So you have both properties working simultaneously. So a good example of uniform is this picture on the bottom right. So a good example of uniform is where if you were located in your universe and you look out and in any direction you see the same. That would be the color yellow. And then in any angle it doesn't change that same color. So this would be an example of uniform. Everywhere you look in all angles and in all directions, you see the same. Now let's say we started out with a really deep yellow really close to us. It's really deep and thick in all directions and in all angles. Now let's go out a ring and make it thinner. It's still the color yellow in all angles, and it's the same intensity in all angles. But compared to the inner ring to the next outer ring, the outer ring is a little bit faded or lighter than the inner ring. This is still an example of uniform. It's still the same in all directions, and it's still the same along the radial lengths. Now let's draw another third outer ring, but this time we're just going to draw it like a wispy, and I'll draw it as dashed lines. So think of a fog, a light, faint fog. So everywhere you look, it is still the color yellow. It's just a lighter intensity. And in every angle you look, it is still going to be that same intensity at that same radial location. So this is still an example of uniform. The intensity decreases as we move out, but it is still uniform. Now let's turn to the cosmological principle. The cosmological principle is the assumption that any observer in any galaxy sees the same general features of the universe. In other words, the universe is uniform. And by uniform, we mean on large scales. So small irregular features may be there, but overall on large scales, all observers in all galaxies see the same general features of the universe. The cosmological universe implies that there are no special places in the universe. What you see from the Milky Way galaxy is typical of what all intelligent creatures see from their respective homeland galaxies. Now, if you think about that, what that means is that we cannot find the edge of the universe. Everywhere we look, we see the same thing, so we don't see an edge. And therefore, if we don't see an edge, we can't define where the center is. So therefore, a more modern definition of the cosmological principle is that the universe does not have a center or an edge. So let's think about this here. Imagine you are a tiny skin piece and you're in the third layer down. You're not the outer skin layer, you're not the most inner skin layer, you're just the third layer down from the outside, and you're just one tiny piece of skin. And everywhere you look, all you see is another piece of skin. And you can't find where the end of the skin is. So from your point of view, all you see is skin everywhere. And so from your point of view, you can say that there is no limit to the skin, and therefore there is no edge and there's no center. So for you, you would have the same cosmological principle as we do on the large scale looking around at the universe.